Hello all. In this video, we'll be discussing about Leetcode problem number 6, that is zigzag conversion. So here you are given a string and you have to write it in a zigzag pattern on a given number of rows. So let's directly come to the example. So here this is the string and you have to write it in a zigzag pattern in 4 rows. So this is the zigzag pattern. Once you have written it, you can combine them line wise and then you will get the desired output. So now let's see what approach we can follow it. The first approach can be as simple as just initializing a 2D array where R represents the maximum number of rows allowed and N represents the maximum length of the string. At the initialization of this algorithm, what we can do is we can take two variables R and C and initialize them as 0 as we will be starting from here, that is 0 0 indexes. Here R represents row num and C represents column number. Also, we'll be tracing the upward and downward movement according to the pattern. Once we'll be traversing downwards, we'll be incrementing the row only. And if we'll be traversing diagonally upward, then we'll be incrementing the column and decrementing the row. So now let's simulate the algorithm. So first character is P. Since we are starting from here, we certainly have the only direction as downward. So we'll be moving downward, that is R++. Next element will be placed in this position. Next element R++ Y and then R++ as P. So since we have encountered the maximum row number allowed, so now we'll be traversing diagonally upward. So the next element A will be placed at this position, that is row minus minus and column plus plus. So again we'll be following the same pattern for the next one, that is L. The next will also be placed here. So now since we have encountered the minimum row number, that is 0, so again we'll be traversing downward. So it will be followed till I, then again we'll be moving diagonally upward, R, I, N, and then again downward. And since the string has finished, so this will terminate the algorithm. So now if you can observe that we are having a section wise approach here. First of all, in the first section, the downward movement was traced and then diagonally upward. Similarly, in the next section, again downward and then upward, then again downward. And if there must be more characters, then we must have traversed upward. So this is the common approach that is being followed section wise. So as of now, once you have got this pattern, so for the answer, we'll be traversing each and every element of the array row wise and we'll be printing the non-empty elements. So since we'll be traversing each and every element of the 2D matrix, so that's why the time complexity, the maximum time complexity comes out to be row number into number of elements in the string. Okay, and since we have initialized the 2D matrix also, so the space complexity will also come out to be R into N. So now let's go with the second approach, which is more efficient than this. So instead of initializing the complete array, what we can do is we can initialize an array of strings. So here it is shown that we have row numbers as 4. So that's why we have initialized an array of a string of length 4. So now we'll be doing the same thing as earlier. We'll be tracing the upward and downward movement, and by default the first movement will be downward, of course. So let's start. Since it is P, we'll be writing the P at the 0th position, A at first, Y at 2 and P at 3. Now we have encountered the maximum number of rows, so we'll be traversing up. Now we'll be appending A at the end of Y. Then again minus minus, then we'll be appending L at the end of A. Then I, then we'll be moving down is S, then H, then I, then again up, R, I, N, and then down, so G. So now the string is over, so that's why the algorithm will terminate. So at the end, we'll be just going one by one and we'll be printing the output as A, L, S, I, G, Y, A, H, R, and P, I. So the time complexity for this is, since we have traversed the array once, so the time complexity will be n, as well as since we have just stored n character, so that's why the space complexity will also come out to be O of n. However, the space complexity for this can also be reduced in the next approach, that is the most optimal one. So the third approach says be observant. So if we just go the section wise, so first of all, for the third approach, these two variables are very important. First is section char limit and the second is characters count. So let's understand them one by one. First says what is the section character limit? How many characters are there in a particular section? So let's count it in terms of row number, that is R. So here there are 6 characters. So we can also see that 1, 2, 3, 4 is equal to number of rows. Also, there must be twice characters, but this last row is not having any character and first as well is not having any character. So I can easily write it as 2 twice of row number but minus 2 characters, since first and last are not having any characters in that particular section. So that's why it can be easily written as 2r minus 1. For this, we can write 2 into 4 minus 1, which comes out to be 6. So here, for every section, the section char limit is 6 in this case. So this is the first parameter. The second says characters count. So if you are observant enough, so what you can see is the difference between this and this is 6. Since I have written the indexes here. So difference between 5 and 1 is 4. Difference between 4 and 2 is 2. And here it is 0 only, sorry. So now again, if I go to the next section, then again it is 6. So it is 4, it is 2, again it is 0. So if you can see that across the section, a common pattern is there for the number of characters for the number of in between characters, right? So what we have to do is we have to calculate it in terms of something like section char or row num. So we can also write this number as 6 minus 0, 6 minus 2, 6 minus 4 and 6 minus 6. Here, if you can see that what is the 6? 6 is actually representing the maximum section characters limit. So if I just subtract this numbers from this, then I'll be actually getting this in between characters count. So this can further be used as 6 minus 2 into 0, 6 minus 2 into 1, 6 minus 2 into 2, and 6 minus 2 into 3. Here, this is basically the row number which says first row, second row, sorry, 0th row, first row, second row, and third row. So these are the row numbers. Then we can actually get the in between character count. So I think we are done with the basic variables needed for this algorithm. Now let's go with the algorithm. So here we have seen that section character limit is 6, and now we'll be going row number wise. So first and foremost, we'll be having look on the number of characters that needs to be present in the next section. Otherwise, we will go to next section. So since this is the first row, we can easily see that first row and the last row are not having any extra characters. So we can directly switch to the next sections for these two cases. So we'll be starting from 0th index. Then we'll directly be switching to the next section. Next section is after plus 6, right? Section character limit is 6. So if I'll be adding it, I'll be getting the next section. So here it will be 6, then again plus 6, then it will be 12. So I can directly access these as 0th index as P. Say I have initialized an S. So S is having a P here. Then I am writing the 6th character I, and then I am adding the 12th character as N. So I am having P, I and N in S as of now. So now when I'll be starting with row number 1, I'll be initializing it with 1. But now since character count is 4 here, so what I'll be doing, I'll be adding the next character to my bucket. So what I'll be doing, 1 plus 4 gives me 5th index, right? So 5th is L, okay. So now since there are only 2, if you can just go back, so there are only 2 characters, right? So I'll have to go to the next section now. So now I'll be going to the next section by adding plus 6 to 1. So I'll be getting 7. Then I'll be again writing plus 4, that is 11. Again next section plus 6. Now it will get me 13. So now if I just go for this, one is A, next is L, then 7th is S, then 11th is I, and 13th is G. And further this will be added to this, so this will I'll be having this output in S. Again for the second one, let's go with 2. Then next character is after 2, so I'll be having this 4. Then I'll be moving to the next section again, 8. Then I'll be going to the next words within the section, that is 10. I'll be moving to the next section, that is 14, but since it is out of bounds, so I'll not be considering this. So as of now, we'll be having Y, then A, then H, and then R. And further, we'll be appending this to our S. So now the last one, since we have to treat first and last row different, since there were only one character, so I'll be directly jumping to the section wise. So that's why 3 plus 6 gives me 9, plus 6 gives me a 15, which is out of bound. So basically I'll be having P and then I, which I'll be adding to this as output. And finally I'll be having this string as final output in S. So I hope the algorithm is understandable. The space complexity for this is O of 1 only, as I have only used one string in this, whereas the time complexity is O of n, since we have traversed the complete string one time. So this comes out to be the most optimal solution. This is time complexity, and this is space complexity. O of 1 and time complexity is O of n. So now let's switch over to the code. So here we have initialized our n, taken the section character limit as per the formula. Then we have taken the next index as 0, which will be used in the algorithm intermediately. And then we have initialized a string as answer that will be returning. Now for each row num, we'll be initializing the index. Till index is within the bounds, we'll be adding that particular index to the answer. And now we'll be looking for next character within the section. Here we have taken care that current row is not the initial as well as not the last one. So if there are more characters, then as per the formula we have calculated the number of characters that we have to skip, and then we'll have calculated the updated index, and if it is within the bounds, we have appended that to our answer. So once we are done with the section, now we have updated the index to move to the next section. So this will actually complete the section wise count. So once we are done with this complete algorithm, that we are done with all the rows, we'll be having the final result in our answer that we'll be returning. So that's all from my side. Thank you for watching. Have a nice day.